Okay, ladies and gentlemen, we're going to continue here with area between curves. Let's just make sure our audio is on. We're gonna do some more of these questions. How about like 9? Well, we're gonna continue. Okay, so area between these two curves, there's a bounded region here, and that just means there's boundaries. So if we look at the details here, this is the bounded region they're referring to. All right, let's double check that that's there. Okay. So we need to identify, remember, the top curve and the bottom curve. So I'm drawing our approximating rectangle just to kind of remind people of where this comes from. So you got the curve on top and you got the curve on the bottom. Now, they give you a parabola here, and I want you guys to see the parabola is the one that has the x squared term. So there's your parabola. If I can sketch that a little bit. There we go. And the second curve is the line. So it's equation of the line. So you want to be able to identify which is which. It's not that hard to do. Okay, x squared, that's the parabola that opens up. The curve that's 2x plus 5, that's the equation of a line from beginning algebra. So we know how to actually go about this. So if we're going to get the area here between two curves, remember this. This is going to be the top curve minus the bottom curve. And so we identify the top curve to actually be the line, which is 2x plus 5, and we're going to subtract the parabola now because that's the bottom curve. And let's move this over. Okay, do a little bit of algebra now. So this is where the algebra comes in. And I'm going to erase all of this because I want to remind people of another sort of issue we may have here, right? We need the lower limit and the upper limit here. So this is like the A value and the B value, right? So we need those values. Now, there's a couple of things I want to remind people about. Some of these questions are very nice. They're very nice because you can visually determine those points of intersection. For example, this is going from -1 up to 3. So whoever wrote the question, not necessarily me, but whoever wrote these questions did it in such a way that these points of intersections can be found pretty easily. They can be found graphically just by looking at the picture. But as you guys know, okay, even though we can do this graphically, right? Generally speaking, how you find points of intersection is by letting these curves be equal to each other. So they share the same x and y coordinates. What that means is you get x squared plus 2 is 2x plus 5. So if I want to find those points of intersection, I got an algebra equation to solve. This is going to be a beginning algebra question. So I'm going to go up here and remind people a little bit of some beginning algebra, just for fun, I guess. You're going to subtract 2x. You're going to subtract 5 from both sides. You're going to get x squared minus 2x minus 5 equals 0. Here's a quadratic equation that can be solved by factoring. So using that algebra again, you guys recall the crisscross method. You can solve this equation. You're going to say, oh, let's double check. X squared plus 2 is 2x plus 5. So Yeah, we did not do this arithmetic. So -5 plus 2, that'll be a -3. So, okay, now we're good. Now we can factor this. So we'll have x minus 3. And let me double check. We're going to, if you guys wanted to do the crisscross method, you guys remember 2 numbers multiplied together is -3. When added is -2. So what are the 2 numbers multiplied together? Which is -3, but when added is -2. It looks like it's -3 and +1, right? Double check. Yeah, okay. So x minus 3, x plus 1 here. So, okay. X minus 3, x plus 1. And using the zero product rule now, I'm going to get rid of what we have here. That means, again, that x plus 3 equals 0. It also means x plus 1 equals 0. So it gives you x as -3, and it gives you x as -1. So these are our 2 solutions here. Okay? -3. And I think I screwed up. I screwed up. I got to get that. There we go. +3. There we go. All right, now we're good. So as you guys can see by the algebra, setting the curves equal to each other, yeah, you're going to get these limits as you graphically can actually find. So, hey, whoever gave you the graph in the question was very nice. You know, you don't really have to do the algebra in that case, but, you know, we do want to recall and give homage to a topic that's vital to everything that we do. Okay, now distribute here. So that area is going to be, I'm going to put the integral here. 2x plus 5 minus x squared minus 2 from -1 to 3 dx. And let's see what we get now with that. Let's make sure we do our algebra okay. 2x minus x squared, -5, or +5 minus 2, that's a +3. So good. -1 to 3. (2x squared over 2). We're going to integrate. Minus x cubed over 3 plus 3x. X is -1, x is 3. So you get x squared minus 1/3 x cubed plus 3x. We evaluate that from -1 to -3 here. So in that case now, remember this, you're going to have the antiderivative f of 3 minus f of 1, 3 cubed minus 1/3, 3 cubed, plus 3 times 3, minus -1 squared, minus 1/3 -1 cubed, 3 times -1. So there we go. So let's do this arithmetic. We get 27 minus 27 over 3 plus 9 minus -1 squared is +1. -1/3 times another -1 is a +1/3 minus 3. Let's get out some more paper. So now 27 plus 9, you're going to get 36 minus 27/3. Minus in parentheses here, 1/3 minus 2, 36. Why don't we say 27/3 is going to be a 9, right? Is that 9? Yeah. All right. So, I mean, we could do it this way. How about that? Let's go back. 9. So it really gives us now, right, say 9. We're okay. 27 minus 1/3 plus 2, which is 29 minus 1/3. 29 minus 1/3. Okay. So if I multiply now the top times 3 and the bottom times 3, there we go. We're going to get now 87 thirds minus 1/3, which gives you 86 thirds. So, okay, ladies and gentlemen, that's the first kind of question we have here. This is number 9. So let's proceed to the next odd number because, I'm having you guys do the odds. So let's go to number 11 here, another area between two curves, a bounded region here. Alrighty. This is the bounded region. So again, points of intersection. Looks like down here, this will be a -2. And a point of intersection here. You guys can see that. Looks like that's 5. So I guess I can say here x is 5, and over here x is -2. There we go. Alrighty. Rectangle. Approximating rectangle, we need the top curve, which is the parabola that's opening down. And that's going to be the first one because you have the -x². That's a parabola opening down, so that's the top curve. And then the bottom curve is x² minus 5x. That's the parabola that opens up. And area now is going to be the integral from -2 to 5. Y top minus y bottom. Okay, so the top curve again, parabola opening down. That's the 20 plus x minus x², minus down here the parabola opening up, which is x² minus 5x. Okay, we're going to put that dx here. And that's a 5. Okay, do some algebra now. Distribute here, multiply the difference there with a -1. Remember, that's really a -1 there if we want to go down there. Okay. All right, so we have -2 to 5. 20 plus x minus x² minus x² plus 5x dx. $20. Now you're going to have plus 6x minus 2x² dx. 20x, 6x² over 2, 2x cubed over 3, x goes in -2 to 5. So 20x plus 3x² minus 2/3 x cubed, -2 to 5. We get f of 5 minus f of -2. Okay. So let's double check to see we're fine. 20x plus 3x squared minus 2/3 x cubed. All right, let's double check here, right? So I just want to remind people here. There's your antiderivative. We're going to evaluate that antiderivative at the endpoints where x is 5. So 20 times 5 plus 3 times 5 squared minus 2/3 5 cubed. Negative 2. Let's double check that. So 20, that's 100 plus 3 times 25, right? So that'll be 75 minus 2/3 of 5 cubed, 125. Subtract that from negative 40 plus 12 minus 2/3 times a negative 8, which would be a plus 8 now. So let's kind of keep it that way now. 175 minus 2/53 minus a negative, well, you got negative 40 plus 12, negative 28, and that'll be plus 16/3 here. 175 minus 2/53 plus 28 minus 16/3. Okay, so I'm going to do some arithmetic here. 175 plus 28 now, that looks like that's going to be 203. And then negative 2/53 minus 16/3 looks like that's negative 266/3. So doing some more arithmetic here, we'll end up with 203 times 3. 609/3 minus 266/3. 609/3 minus 266. 343/3. All right. So it looks like it's okay here. Number 11. Okay, there you go. Here's 12. We're going to do now 13 here. All right, 13. Area between the curves here. Now, we're going to go about this again in a very interesting way. Now, it might be in this example, you go, wait a minute, I cannot find so easily. Doesn't look like, the points of intersection line up in a way that I'm used to seeing on these lines. Not so easy to find. So we're going to need to get these points of intersection, ladies and gentlemen. So, but I also want to point out to you guys that this curve here, the bounded region we're looking at, this particular bounded region is symmetric about the origin. That means your integral is going to be over an odd function. And we're going to use that properties because that looks like this is over a symmetric interval of an odd function. So the graph tells me, because of the symmetry, that the function we integrate is going to be odd, symmetric about the origin here. I'm going to say symmetric about both x and y axis. But that's what it means. It's an odd function. So remember what that was. If it's over a symmetric interval and we find out that that is negative a to a, where that function is odd, right? We can take double the area from 0 to a of that integral. And I suspect, just by looking at the picture, that it's odd. Okay, so some important details. Now let's find this. Let's find the points of intersection, because this is an example where it's not so easy to get. So you say, well, how do we do that? Set the curves equal to each other. And I'm going to go up here. Maybe we'll get some paper here on the top. Well, I guess it doesn't matter. Down here, let's add it below. So for your points of intersection, set the curves equal to each other. 1/2 x equals. Okay, so we're going to find the points of intersection by setting the curves equal to each other and solving for x. So y equals y again, which means 1/2 x is x square root of 1 minus x squared. So you got to solve for x now. Okay. So bringing this down, if I can, let's do some algebra. I'm going to look at it this way here. Since I see x on both sides, I'm going to subtract the term here and get that equal to 0 here, right? So I notice I have that x on both sides of my equation. I'm going to factor out the x. So I have x, this is 1/2 minus the square root of 1 minus x squared equals 0. This means x is 0, and it means 1/2 minus the square root of 1 minus x squared is 0 here. So one solution, or one interception, point of intersection, happens at x is 0, and you can see that here in the picture. So this is where the first point of intersection actually is. We'll put it down there, x equals 0. Okay. Now, the second equation here, I can translate this term, meaning we get 1/2 is the square root of 1 minus x squared now. We're going to square both sides now. So 1/2 squared will be 1 minus x squared. We're squaring both sides, just so you guys know. And now that gives us 1/4 is 1 minus x squared, which actually means x squared is 1 minus 1/4. If I translate terms, move them on the other side, and that means x squared will be 4 over 4. We're going to do some arithmetic. Or x squared will be 3/4. So by the square root formula, x is plus or minus the square root of 3/4. X is the square root of 3 over the square root of 4, or x is the square root of 3 over 2 now. And we need the plus or minus. There's two solutions here. So let me make this a little bit more clearer for you guys. You guys can see that. So x is going to be plus or minus the square root of 3 over 2, because the square root of 4 is actually 2. Two solutions here. Plus or minus square root of 3 over 2 now. So this is, if we can write that clearly, square root of 3 over 2, and this is minus the square root of 3 over 2. And these are the x values that we're looking for. These are the vertical lines now. Okay, so we did a little bit of algebra here because this isn't always so clear. These are my points of intersection. So for the integral now, you say, well, I'm going to use the fact that we have that symmetry. The function here is symmetric about the origin, this graph, this region. So, I mean, I don't even have to check that it's odd because it will be. But I'm going to put 0 now, square root of 3 over 2 to integrate. This is still y top minus y bottom dx. And let me make that nice and clear. I'm having trouble with that square root of 3 writing so small. Okay. We just have to identify the top and bottom curves. Now, this is really nice because if I really dive deep into this idea here, we do a deep dive. The fact that I'm focusing on this portion here. Let's get the gray. I'm looking for gray. My focus in terms of integration is on the right portion. Now, that's kind of nice because of the fact that I can now, when I draw my approximating rectangle, identify the top curve now. It's the blue curve, which is not the line. So the top curve is y top is x square root 1 minus x squared. The bottom curve is the line, 1/2 x. So, all right, we got top and bottom. So let's get this going here. Okay, I'm going to have to move everything down here. Top curve we said was x square root 1 minus x squared, and the bottom curve is minus 1/2 x. So my area is going to be to integrate from 2. This is all in terms of x square root 1 minus x squared minus the 1/2 x dx. Okay. Now I'm going to do this here. How can we? Let me describe it this way for you guys. Let me see if we can elegantly integrate. This is what I mean by that. So we're going to do it a couple of ways, maybe. Remember this integral right in here now. We're going to use u sub, where u is 1 minus x squared. Du is minus 2x dx, or we'll say dx is du over minus 2x. So if we're going to use u sub here, I guess we're going to have to separate those integrals here. So you have 0 to the square root of 3 over 2 x square root 1 minus x squared dx minus that 2 is still there, and we're going to integrate 1/2 x dx, the same limits. So I'm going to have to separate it again where the u sub information goes down here. Okay. And this integral, if I get more, do I need more? No. This integral over here is a separate integral. So I don't know what colors to start to use here, but this is going to be a separate integral. So, I mean, sometimes they call that like A1 and A2. Maybe not. Integral 1, integral 2. Yeah. And then over here, you say, well, this is the u sub. So let's paint that red for u sub. Okay? So I'm going to do 2 separate integrals. Yeah, we'll put it in red. So that's 2. Well, 2x square root of u, dx is du over minus 2x. Cross out your x's. This is x is 0. This is x is square root of 3 over 2. Now you have to convert that to u. So we know u is 1 minus x squared. So if I put 0 for x, that u now becomes 1. If I put the square root of 3 over 2 for x, u is 1 minus the square root of 3 over 2. Don't forget we square that. 1 minus 3/4. This will be 4/4. U is 1/4. So my upper limit now is now in terms of u, and that would be u is 1/4. So that integral becomes negative. And maybe I'll put it in red, I guess, because 2, don't forget the negative sign. Negative u to the 1/2 du, where u is 1, we got 1/4. So we get negative u to the 1/2 plus 1 over negative 1/2 plus 1, evaluated from 1 to 1/4. If I move this all out of the way. Two halves. Negative u to the 3/2 over 3/2, 1 to 1/4. So this is now going to be negative 2/3 u square root of u 1/4 to 1. Now that's the first integral. It's not even the second integral. So this one's going to be some work. Let's get some more paper. I don't even know where the paper's at. Where are we at? Down here? Okay. Add a page. All right, so that first integral, 2/3 times 1/4 square root of 1/4 minus the negative 2/3 times 1 square root of 1. So looks like it's a negative 1/6 times 1/2 plus a 2/3 maybe. Let's double check our work. Let's double check the arithmetic, because we're checking this over here. Negative 2/3 times 1/4 square root of 1/4 minus the negative 2/3 times 1 square root of 1. Okay, that looks okay. So yeah, it looks like we're on the right track. So that's negative 1/12 plus 2/3. Multiply the top and bottom by 4. Negative 1/12 plus 8/12 will be simply 7/12. Seven twelfths. This is the answer for the first one. Thankfully, the second integral is a lot easier. So this is minus again x dx 0 square root of 3 over 2. And so that'll equal the minus 1/2 x squared 0 square root of 3 over 2 minus 1/2 square root of 3 over 2 squared minus the negative 1/2 0 squared. This portion over here is going to be 0. Minus 1/2 times 3/4, looks like. So that's a negative 3/8 for the second integral, maybe. Let's double check our work. Negative 3/8. Negative 1/2, 3/4, negative 3/8. So, doing some more arithmetic. Where do we go here? Negative 3/8. Yeah, right up here. So this portion, negative 3/8. Let's keep track of these things. Okay. So 7/12 minus 3/8. I'm going to try to go back up here. Okay, so 7/12 minus 3/8. So we're going to multiply the top by 2, the bottom by 2. We're going to add unlike fractions or subtract them. 14 over 24 minus 9 over 24. So their final answer is going to be here. It looks like it's 5 over 24. So, ladies and gentlemen, that was fun. 5 over 24 will be your final answer. Just double check our arithmetic. 7 times 2. Yeah, 5 over 24. Okay, that's number 13. All right. Okay, 14, and now we got 15, and I'm trying to double check. Let me check something here in our communication. Looks like we did do 15, so I'm going to leave it there in my communication. And then we're going to do 17 now. Okay. Bounded area now. Now we have functions x equals a function of y, x equals another function of y. We have the right minus left. This is now, find the bounded area here. Let's see if we can find that here. Here we go. And it looks like it's just right in here. Yeah, there's the bounded area. Okay. Points of intersection. And they actually were nice in that they gave it to us. They say here y is 0 here. And they say here y is pi over 2. So how that looks now for the area, we're going to do the approximating rectangle. There it is. It's actually bigger than what it has to be. You guys can see that. But we need the right curve minus the left curve. Okay. So which one is which? Well, well, we got x's sine. So here's the x equals sine y. Looks like when I did this years ago, I painted the colors for students so they can see it a bit better. Here's the blue. That was nice of you, Mr. Judge. Boy. So the right curve is black and the left curve is actually blue, if you guys can see that, right? Let me erase it so you can see better. Let's erase that. And really, the approximating rectangle is much smaller. All right. So here's your area. It's the right curve minus the left curve. So now we're going to go from 0 to pi over 2, x right minus x left dx. So again, the right curve is the black curve, so it's sine y. So let's find the right color here. Maybe we don't need colors. You're fine. The left curve is 1 minus cosine y. dy. Let's change that. dy. Okay. Apologize, you guys, because this is now going to be delta y. You guys remember the approximating rectangle will be delta y now. If I just get rid of those left and right. So it's delta y. So that's a dy down here. Good. So it looks like we're good now. So 0 pi over 2 sine y minus 1 plus cosine y. So let's get the antiderivatives now. Minus cosine minus y plus sine y. 0 pi over 2. So don't forget, this is you're gonna evaluate this at f of pi over 2 minus f of 0. Minus cosine pi over 2 minus pi over 2 plus sine of pi over 2 minus a negative cosine of 0 minus 0 plus sine of 0. So let's just double check, okay? Because, it's pretty simple to make that kind of mistake. I mean, this is kind of reminding people. So now we got to think of what's cosine of 90 degrees. You got to think of those cosine curves. 0, sine of 90 is 1. Cosine of 0, ladies and gentlemen, is 1. And sine of 0 is 0. So we get negative pi over 2 plus 1 minus negative 1. All right, let's double check here. Okay. Y is 0 pi over 2. Is that pi over 2? Okay. Let's double check. Negative pi over 2 plus 1 plus 1. So it looks like this is 2 minus what? Pi over 2. And that kind of sounds about right because it's a positive answer. All right, looks pretty good. Negative pi over 2 plus 1. Let's just double check. Negative pi over 2 plus 1 minus a minus. That's 2. 2 minus pi over 2. There you guys go. All right, now that brings us up to question 19. All right, let's see what 19 looks like now. So, yeah, I think again in this situation, what I did years ago when I wrote these things for people. Point of intersection here, point of intersection here, and point of intersection here. So, what does that mean? We go through y equals, looks like it's 1, y equals 3. Over here, y is negative 5. And then here, y is negative 1. All right, so you're kind of lucky in some ways. We got 3 solutions. You could check the points of intersection if you like by setting the equations equal to each other, solving for y. So this is x equals x now. And so just double check here that we have those lines through the appropriate places. Because now when you find the area, this is the important thing. When we draw those approximating rectangles, okay, we have that intertwined situation. Doesn't look like we could use any sort of symmetry here. It's not a symmetric interval, So when we do the work now, we got 2 situations now. The blue curve is on the right, so I'm going to keep that blue, XR. The black curve is on the left, so this is the BXL. And then here, the black curve here is XR, and then the blue curve is XL. So the area is going to be A1 plus A2, where this is A1 and this is A2. We intertwine. Those curves are intertwining in these pictures. So you got 2 areas to find, okay? So let's set this up and let's write this down. The first area is defined to be the integral from -1 to 3, where the right curve is blue. 40 minus 6y squared minus y cubed. There's my right curve. Now minus the left curve. We're going to need more paper. I'm going to move it over. Y cubed minus 26y plus 10. This would be a dy. So here's your A1. And maybe we should do it this way here. Let's pick some colors. And let's not do that. Say gold here. That's what I'm talking about. This is your A1. Silver. This is A2. Let's get rid of that one. So I have to define that for you guys based on this picture here again. So A2 now is going to be, we're going to integrate from -5 to -1 here. Okay, the black curve is on the right. So that's y cubed minus 26y plus 10. Minus the blue curve on the left, which is 40 minus 6y squared. Minus y cubed. dy. So right in here, ladies and gentlemen, you are going to do some algebra. There's 2 integrals here. So I guess maybe we can move this second one down and let's give it the right color now. So that's A2 here. So you guys are aware of that. Let's see what we get. Okay. doing the algebra. Okay, let me remind people. 40 minus 6y squared minus y cubed minus a y cubed plus 26y minus 10. So that gives us 30 minus 6y squared plus 26y minus 2y cubed. Let's just double check. All right, let's do the algebra down here now. Two y cubed minus 26y plus 6y squared minus 30. So your second integral here, -5, -1, 2y cubed minus 26y plus 6y squared minus 30 dy. So here we go. Okay, so you're going to have to get these A1s and A2s now. So, ladies and gentlemen, here we go. Let's do that. Let's get A1 now. So I guess I have to copy everything. And let's get this going here. So, all right. So let's try this one. This is A1. So 30y minus 6y cubed over 3, 26y squared over 2, 2 to the 4th over 4. We evaluate that from -1 to 3. $30y minus 2y cubed plus 13y squared minus y to the 4th over 2. Evaluate that from -1 to 3. So this will be 30 times 3 minus 2 times 3 cubed plus 13 times 3 squared minus 3 to the 4th over 2. Minus. We should just get all kinds of paper going here. All right, let's move this down here. So we say 30 times -1 minus 2 times -1 cubed plus 13 times -1 squared minus -1 to the 4th over 2. 90 minus 2 times 27 plus 13 times 9 minus 3 to the 4th, okay? 8 1/2. Minus, so we're going to put that in parentheses here, -30. -2, that's a +2 plus 13 minus 1/2 now. So let's do just a little bit of this arithmetic here. I'm going to erase it. 2 times 27 is 54. 13 times 9, if you guys want to try to do that arithmetic, right? 13 times 9. It's 117. Okay, and I'm going to keep it that way. Now, we're going to add the first set of parentheses, meaning 90 minus 54 plus 117. You're going to get 153 minus 81 halves. That's the first set of parentheses, minus negative 30 plus 2, negative 28 plus 13. Looks like it'd be a negative 15. And that's still minus 1/2. Take a look at why I'm kind of doing that. All right, so double check your arithmetic. Now, this is 153 minus 81 halves, okay, plus 15 plus 1/2. So it looks like this is 165. Sorry, 168. Minus 80 halves now. 168 minus 40. 168. So 168 minus 40 is 128. So ladies and gentlemen, this is 128. So that first integral, A1, and I guess it's gray. Now let's double check the color. 128. Let me do this here. Let's write it down. 128. Yeah, it was A1, 128. So maybe put it all the way. Where do we first see it? A1 is 128. I'll just put it down here, okay? And I think the color is gold. So A1 is 128. I'm going to do that here. Remember, we're going to add it with A2 now. So we're going to do A2. So that was gold. Let's change your color there, your gold or whatever that is. Now do the gray or silver. Let's do the second integral here. Okay. Copy second integral. And we need more. And that was dy. Okay. 2 out of the fourth over 4. 26y squared over 2. 6y cubed over 3 minus 30y. And that's going to be from negative 5 to negative 1. So let's write this down. Y to the fourth over 2 minus 13y squared plus 2y cubed minus 30y. Value from negative 5 to negative 1. So this would be antiderivative evaluated at negative 1 minus that antiderivative evaluated at negative 5. I didn't do that in the last one, so I apologize, but not a big deal. Hopefully by now you guys understand how this process goes. So let's try this out. Negative 1 to the fourth over 2 minus 13 times negative 1 squared 2 times negative 1 cubed minus 30 times a negative 1 minus, this is really a one set of parentheses again. And now we're going to try that at negative 5. So you get negative 5 to the fourth over 2 minus 13 times negative 5 squared 2 times negative 5 cubed 30 times negative 5. Okay. I might even get another page out here, so let's do that. All right, now, we're going to have to do some arithmetic. Now, the thing about raising a negative number to a even power makes it positive. So you get 1/2 minus 13 times 1 plus 2 times negative 1. Now I'll do plus 30. There's your first set of parentheses minus the second set will be. Now you got a negative 5 to the fourth power. Again, a negative number raised to an even power is going to be a positive, so that's going to be 625 over 2 minus 3 times 25 now, plus 2 times a negative 125 plus a 150. 1/2 minus 13 minus 2 plus 30. Minus, you have what? 625 halves minus 75. 125 times 2, that's a negative 250 plus 150. Okay. Yeah, I mean, I could just move. I don't have to put equal. I did that to kind of clarify, but I'm going to move this down. Maybe that's better. So you can double check some of that arithmetic here. You get 1/2. And did I need extra? No. We got negative 13 minus 2. That's negative 15 plus 3. That's positive 15. And you got 625 halves. Negative 75 minus 250 is negative 325. So I got negative 325 plus 150 is going to be a negative 175. So let's double check, okay? Looks like we're okay. 1/2 plus 15 minus, we're going to distribute the negative sign. You now get 175. We're going to add the numbers together, right? The whole numbers is 190. And then you got 1/2 minus, 625 halves, which would be negative 624 halves, looks like. Let's double check. And then 190 minus 624 halves, it looks like it's going to be really 312. Okay, let me double check here, okay? All right, so 190 minus 312. So we have 190 minus 312 gives you a negative 122. And I think that was silver. Yeah. So, moral of the story is that A2 is negative 122. Silver or gray, whatever you want to say. So remember what we said here. Your area is going to be A1 plus A2. So I got to go all the way back here. All right, A1, gold. What were you, A1? I barely remember you. 128. So we got 128 for A1 plus the negative 122. So it looks like my area is just 6. Nice. Your area is 6. So all of that means here, area is 6, ladies and gentlemen. And, we used some. Let's get rid of all the colors. Let's get rid of all the drama. Bounded area here, ladies and gentlemen, is the value 6. This is the area. And yes, the curves intertwined at this location here. So it's 2 integrals. This first one is 128, and the second one was a negative 122. Anyway, and that's the total area we got with 6. Number 19. Okay. $21 now. Bounded area. And we're going to take a look at this one because notice what they did in this question for 21. Okay, the bounded area, the x equals 0, that's the y-axis. And they give you y as a function of x. So now your approximating rectangles are back to being vertical. And you might say, well, why is that? Because of the fact that you got y is a function of x for both of these. And so that's going to be your, y top minus y bottom. And what's even nice here is the curves here. This is the line x equals 2. And they gave you the x-axis when they said x equals 0. So not too shabby. Right, take a close look there. So my area will be, we're going to integrate from 0 to 2. I like 0, y top minus the y bottom. This is back to being dx now because that approximating rectangle, you have the delta x, partition the x-axis. So which is the top curve? Well, it's the blue curve because the Mr. Judge that did this worksheet years ago, I guess gave you the colors there. So the blue curve is on top, I guess. Top minus what? Bottom. Minus the black curve, x squared minus 6. Let's get some paper here. Let's double check. 6 minus x cubed minus x squared minus 6. Got some algebra to do. Six minus x cubed minus x squared plus 6 will give us 12 minus x cubed minus x squared. We got the algebra now. Area is going to be 0 to 2. 12 minus x cubed minus x squared dx. 12x minus x to the 4th over 4 minus x cubed over 3. You got x is 0 and you got x is 2 here. This is the antiderivative again, and we have to do f of 2 minus f of 0. So I do that just to kind of make things clear for myself. And, okay. 12 times 0 minus 0 to the 4th over 4 minus 0 cubed over 3. I like 0 because this whole portion is 0. So we get 24 minus now 2 to the 4th over 4. 16/4 minus 8 cubed. 24 minus 4 minus 8 cubed. 24, that's 20 minus 8 over 3. Now we got the common denominator. 60/3 minus 8/3, and that's 52/3. All right, not too bad. Okay, ladies and gentlemen, I think that's where we're going to stop for some of these here, and I hope you guys enjoyed all of the, the lecture here, or not the lecture, going over some of these problems. 52/3. I'm going to get rid of all the drama here, and remind people here what we're finding. Bounded area here is 52/3. All right.